welcome to today's class. Today we are going to be looking at Git and GitHub. What is Git and what is GitHub, and why is it important to a DevOps engineer and also a Kafka admin? Now, when you go back to the earlier class, the video on explaining what a DevOps engineer does or what DevOps engineering is all about, we discussed about what is called a repository, where the developers can push their code to a central repository where the DevOps engineer will point his or her CI/CD pipeline to that repo to be able to initialize and create the pipeline that he or she wants to create. So Git is what gives us that functionality, what gives us that tool. So Git and GitHub. So in this my diagram here, I'm going to be simulating and trying to draw what the repository is. So we can think of it as like a central point, right? Like a central point, like how we talked about the server. So for example, this is to be understood as a central point in an organization. So typically, this will be our GitHub. This will be our GitHub, and in here we will have repositories. A repository is nothing but a kind of container or a kind of space whereby we put related files or related scripts. So if we have a repository, we could create a repository for specific project. Let's say I want to build a shopping cart kind of application. I can create a repository on our GitHub, which I would call it shopping cart. I could call it shopping cart repository. Now all the scripts and all the collaboration, all the code and everything, folders that we need that are related to this shopping cart repository, they will be created and pushed into this particular repository. Now, if we have maybe another application, order processing application, like an application that processes order, now we can have a separate repository for that, which we'll just call it inside our GitHub. We can then create another repository and we can call it orders repo, right? So in this orders repository, all files and documents that are related to that building that orders application are going to reside in this repository. So when a DevOps engineer wants to create a pipeline, he can create a pipeline to point to this repository. And then this could be sales purchase application. So this other one could be sales purchase, for example, like that, multiple repositories. So a DevOps engineer can create another pipeline that points to this repo. So we keep everything separated in the organization. So an understanding of repositories will allow you know how to point your CI/CD pipeline to specific repositories in your organization. So what is Git? Now, having this understanding, Git offers us a form of collaboration functionality. Now we can have multiple developers in an organization. we can take this to be okay, let's say this is a developer. So now we can have multiple developers in an organization. Let's say we have 3 developers in this organization, right? They all have their work laptop which they are using. So they all have their work laptop which they are using. Can call it. Now let's say this is the developer 1 and this developer is working on a particular Python script, for example, right? Now, working on the particular type Python script, we would not expect the script to be duplicated on this other second developer's laptop and is working on the same thing, and then this one duplicated and is working on the same thing. So it's like a duplicate of work, and it's not very efficient when you are trying to duplicate everything. But these developers, they need to find a way to collaborate with each other, right? So they are the team of 3 developers and they have the idea. They want to work on the entire application, so they can do a division of labor, and this person can work on perhaps the API side of things. This person could work on maybe the button, like the CSS part of things, and then this one could work on some certain functionality part of the application. Now, how would they be able to collaborate to work on the application that they are building? Now, we did establish that when this developer is working on the application, the code base in his or her laptop, these other guys may not be able to know what is going on, right? This one would have to come down to this one's desk to be able to see what's going on here. This one will have to come down to his desk here to be able to see what's going on in his laptop, which is not a very efficient way to actually collaborate in the organization, especially when we have the availability of remote operations. So this one could be in the US, this one could be in India, and this one could be in Canada. So there's no way you would have to come down to meet physically to be able to see what's going on this one's laptop. So they need to find a way where they can host the file. This one can host it in a central location, whereby this one can connect to that location and see what's happening. This one can connect on to this location, same location, and see what's happening. So this is the concept of Git and GitHub. So GitHub is that central point where we can move our files, our application codes into for other members of the organization to be able to access it and see what is going on. So now Git resides on the developer's laptop. Git resides here. Git is what allows us to be able to push the file from the local computer into this remote location. And Git is nothing but a tool, just like how you have Python. That is what Git is as well. So you would typically install Git in your laptop. So for example, we can take an example. This developer started the actual code and wrote perhaps like the API part of the code, right? And then he will then commit. There's what is called commit. We are going to look at that, or the commands that you need to know regarding Git. So he's going to create and write those code and then push it over to the GitHub. Now, once pushed over to the GitHub repository, then these other developers can now take it from, can now clone it. It's called cloning because the file will still remain in this repository up there, and then the developers can clone it into their own local computer. So this other developer can go there at different times, not being dependent on this one. At different time, he can clone a copy of it. Also, this one can clone a copy of it. And then what will happen is, if this one had written something like, for example, he wrote hello from dev1 into a file and push that file into the repository. Now when developer 2 pulls or clones that file into his own local computer, now he will have a copy of that file, and what he will see in that file is same thing. He will see hello from dev1. He's going to see that in the file that he clones. Now the third developer as well is going to clone the file and is going to see the same thing in that file. Okay, so this is what it looks like. Now this guy as well can decide to make his or her own update. Now can decide to make his or her own update, and it can, from the copy of the file which he has in his own computer now, he can also write hello from dev3 and push it. Then he can push it into the repository. He has made an update. He can now push it into the repository, and when this guy pulls again, just to check if there are any changes, when he pulls again, then he is going to find this in the file. He's going to find this in the file, hello from dev3. And then let's say he doesn't push yet. He doesn't have, maybe he's not yet ready to make any changes in the file. So he can just keep it, but he knows that a new line has been added into the file because it has been pushed into the repo, and periodically he can just come and pull the repo to ensure he is up to date with the latest changes that have been pushed into the repo. So when this first developer eventually pulls the repo, at some other time, then he is now going to see this new line. He's going to see this new line, hello from dev3. So this is how it happens, whereby there is collaboration. Identically, what is in here is identical to what is in here. So what is in here is identical to what is in here. So this is how they all collaborate. So when this guy wants to make his own changes, then he comes, he adds and say hello from dev 2. And then when these other guys, they pull again, when this one pulls, it's going to see that a new update has been made, hello dev 2. And when this other developer pulls it, it's going to see hello from dev 2. So this is how the collaboration works, because they are in different locations, but with this they can be able to know. Now when they come into a meeting, let's say their virtual meeting in the organization, they will be able to know and be in sync with all that is going on. So what these are for the developers, what they do, like pushing it to the repository. So this is to understand what the repository is. Now the DevOps engineer, now his or her job is to build a pipeline, right? We established that the job of the DevOps engineer is to build a pipeline that links to this repository. Let's see if this can be bent. This typically cannot be bent, so I will use a different, okay, I'll use this. So now the DevOps engineer will create his or her CI/CD pipeline. This cannot be extended further than this. I'll remove this. Looking to draw, okay, I'll use this. Okay, so the DevOps engineer, this is his pipeline. He is going to be looking to link his pipeline with this repo. For example, link his pipeline to this repository. He will link his pipeline to this repository, and then we have the server. Remember, and then we have the server. Remember that the end goal is to take the application into the server, take the application into the server for it to run on the server. So whatever the developers are doing, when they push it to the repo, then they can run the CI/CD pipeline, and then this pipeline will trigger, pick up the files that are in here and do some building of the file, testing of the file, whatever is necessary, right, to prepare the script or the code base to be deployed into the servers. So now when these developers, they are in sync with their changes, then they push it to the repo, and then they can trigger the pipeline to run. So when the pipeline now runs, then they are going to have this pipeline do whatever steps the DevOps engineer has designed the pipeline to follow, whatever steps he has designed on the pipeline. So this pipeline will now run, take the application, do whatever it needs to do with the application, testing and all and everything, and then deploy it into the server. So the CI/CD pipeline links to the repository and then links to the server. That's like the source to the destination of a typical CI/CD pipeline flow. So when the developers push their code to the repository, then the DevOps engineer's CI/CD pipeline can be triggered to now move that application from the repo and put it into the server. So what happens is it's all in a duplicate format, right? This file will now be pushed into the repo. A copy of it will be taken by the CI/CD pipeline, worked upon, and then deployed into the server. So the file is still here, but the complete version of it is now running in the server. When the developers make a new change, for example, another hello, let me expand this. For example, let's say another hello is written into the file, and then this developer pushes it into the repo. Now there is a new update to the entire code base. Now they can trigger the pipeline again, and the pipeline will take this copy of the latest copy now of the code base, do it, build it, do the testing, whatever it needs to do, the testing and everything, and then deploy it right into the server, be it development server, be it UAT server, or be it production server. So this is the entire idea of the Git and the GitHub, and then we'll go into the practical aspect to see what an actual GitHub repository is, and we can actually look at the commands, see the commands that we can run to actually create a file, save those files, and push those files into our repository. Okay, now to create, first off, we are going to be creating a GitHub account for whoever doesn't already have a GitHub account. And every developer, DevOps engineer, Kafka admin, you definitely need to have a GitHub account. So we do github.com, and we'll say login, right? Or sign up. Let's see. So sign up for GitHub. Yeah, this is what the login page will look like, and I'm going to try to create a new GitHub account. I would advise for some of you to just go with your Google, but let's do email for now. Let's see. Okay, James Gmail. I'll use another one, and then James at gmail.com, and then we'll create a password. I'll give it so for username we can say test dev class. Okay, this username is available, test dev class, or we can say test DevOps class. So we can, okay, this is not available, we'll do test dev class. So we create an account. Upon successfully creating your account, you're gonna have this your own dashboard. You can come here, you can work on your profile, or upload your own picture into your profile. But when you start off, you're gonna have 0 repositories here, right? You're gonna have 0 repositories. So what you're gonna do is you're gonna create a repository, right? When you come here, click on this plus sign button, and then you're gonna click on this new repository. So you can create a repository. You just give it a name. We can call it DevOps class test. So we can give it a name. We can call it DevOps class test, which is available. Then if you want to put a description, we'll say repository for DevOps engineering learning, and we can keep everything as it is, and then you do create repository. Now your repository has been created. So when we come down to here, you're gonna see the repository in the list of repositories. For those of you that will be starting out anew, then you will see it as the first and the only repository that you have. Then this is it, DevOps class test. So this is the repository. For example, I have different repositories, and when you look into any repository, you will see files. All you put in a repository are folders and files in that folder. These are code base. So that is what a repository is. So currently, let's look at our newly created repository. So this is our newly created repository. There is nothing in here. There's nothing in our repository. So we need to push files into our repository before we can see an update into this UI. We can see an update into this UI. So a repository gives us an idea of a concept in Git, which is called branches. So branch is where we actually put the files. So when you put a file into a repository, there are certain branch on that repository that you can put those files. So you can, in a repository, you can have 3 branches. You can create, when you create a repository, it will start off with the one branch called the main branch, and then as you wish, you can create multiple branches. You can create a UAT branch. You can create a UAT branch. You can create a dev branch. You can create prod branch. When you create branch, if you push a file into a particular branch, then from that branch you can make a distinction. So we can have files that we push into main branch. We can have files that we push into development branch, and sometimes they can be a bit different. And for the DevOps engineer, the branching also helps the DevOps engineer to be able to tie the CI/CD pipeline into the repo based on branches. So for example, this is our development server, dev. Then we can have UAT, and then we can have production server, prod. So now the pipeline can be designed in a way that if the trigger is being, if the file is being pushed to the dev branch, then it can trigger the pipeline to actually deploy into the dev environment. If it is being pushed into the UAT branch, then the pipeline can be triggered to deploy it into the UAT server. And then if the code is being pushed into the production branch, let's say prod branch, usually a lot of organizations use the prod branch as the main branch. They use main branch to be their prod branch. Then it can trigger the pipeline to deploy it into the production server. So this is what the branching does. And also branching allows the developers to be able to do whatever they want to do in a branch, which will stay separate from this repo, do whatever they want to do changes, multiple changes, because sometimes your CI/CD pipeline, depending on the organization, can be designed to trigger automatically. So the CI/CD pipeline can be designed rather to trigger automatically once a code is pushed into the repo. It can automatically trigger a pipeline. In that case, the developers would not want to do testing or do changes into the repo without being very sure of their changes and syncing up and approving the changes. So this developer, what he will typically do, he is going to create a branch. He is going to create a branch on his own Git. He's going to create a branch. He's going to create a branch and make his changes into the branch. Now, he will have his changes and his updates in this branch, and then he will raise what is called a merge request. He will now raise what is called a merge request for him to merge his branch into one of the branches, maybe into the development branch, for example. So when he raises the merge request, what happens is this developer, can go over and see the changes in this branch for example, called feature branch. This one can go and see the changes in this branch, and once approved, then this guy can be allowed to merge. And then when this guy now merge, knowing that they have all approved the changes that has been made, then for an automatically triggering pipeline, then this pipeline will trigger automatically and deploy it into the environment or the server that is respective to that branch that the merge was made upon. So that's the concept of branching in Git. Right, so now here is the repository. It is being created with the main branch, and we are going to see that shortly. So to get, we talked about the developers having the copy of the repository in their local computer. So let's try to do that now. I'm a new developer in an organization. This is one of their repo, and I want to have it in my local computer. So I'm gonna click on here to copy this URL of the repo. If you see, this is the URL of this repository, GitHub class test.git. So you'll come to your terminal. We can use VS Code. You come to your terminal, and then you will do Git. Now, if Git is not installed on your computer, then you need to install Git. You can go onto YouTube to see how to install Git. It is very straightforward, but for my own system, I have Git installed. I can do git -- version. This is the version of my Git that has been installed in my computer. So run git clone. I'm gonna cd. Okay. Now we'll do git clone, and then you paste that repository's URL. When you paste it, it's going to clone that repository into your local computer. It has been cloned, and now if you see it, it clones it as a folder. It becomes a folder in here. It becomes a folder in here in our local computer. So we have just done this. We have just done having the link having this copy of the repository. We've just had it copied into our computer, our laptop. So now what can we do? Let us create a file and write hello from dev1. Let's create a file and then we push it into the repository in the GitHub. So to create a file, we can use Linux command, or we can just use simply VS Code, and I can create this file called test.txt. So this file has been created. This is the file. Then I can write into it hello from dev1. Hello from dev1. I save the file and then I will write a git command. This is where we now come to one of the git command. The first git command that we saw is the git clone, which you run most times once. You run it once to get the remote repository cloned into your local computer. So now that we have it cloned, then you will go into the folder DevOps class test, because it creates it as a folder. So we go into the folder. When we do ls, we are going to see that file test.txt that we created. So now we can do git status. Is a command for us to see what Git is tracking. So Git is a version control system that allows us to be able to track the changes that we are doing into a file. So it tracks the changes that we are doing into any file and then that we are pushing it into the repository. So Git, what it does is Git looks at your remote repository, see the changes, looks at your own local computer and also see the changes. If there are differences, it will alert you that there are differences between the repository's code and your own version of the code. So git status. So what is this telling us? It is telling us that on branch main, which I did say that when you create a repository, it starts off creating it in a branch called main. So no commits yet, and then Git has a file that has not been tracked, an untracked file. So it stays in red as Git, trying to let you know that, hey, I see this file, but this file has not yet been tracked. It's not part of my tracking. I see this file, but it's not yet part of my tracking. How do we make it part of Git's tracking? So we'll say we run the command git add dot. Git add dot is to add every file that is in that folder. But if you want to add a specific file, then we'll give it the file name git add test.txt. Enter. Now we can check the Git status again and see if it has changed. Now this should change because now Git has now started tracking this file. So it changes to green and now it tags it as a new file. So Git is letting us know that it's a new file. Why is it a new file? It's because it is in our local computer, but it is not yet in our remote repository. If you see, still this is what we have. This is what we have. No file has been pushed into this repository. So now we are okay with the change that we made into this file. Now we want to push it to the repository. When we want to push it into the repository, there's what Git does. Git, after adding the file and now tracking the file, then we can move it to one more stage called commit stage. So we can commit the file. When you commit a file, it means you're telling Git, hey, these files, I'm ready to push them to the repository. So it's like a garbage collection, for example, how it works. So a garbage collection will package and garbage, just pack up the files ready to dump somewhere, right? So when you do git add, Git begins to see the file. Like we can have two files and I'm ready to only push one of the files into the remote repository for all the rest developers to see. So how do I separate it? I will now commit the one that I want to add into the commit stage. So I will now commit the ones that I've added and the ones that I want to commit into the commit stage. Now, so we will run the command git commit -m is to pass a message. We can say pushing first file into the remote repository. Into the remote repository. Now this files has been committed. Now to push these files, let me clear the terminal. Now to push this file, then we run the last command git push origin main. So what this means is git push the files that are in the commit stage, push them into the origin main. Origin main means the remote repository. Push it into the remote repository, which is the origin of this local folder that I have. So I am having a clone of the remote repository, and the remote repository is the origin of this like repository, right? It is the whole it is the final destination of whatever we are doing. So 50 other developers can have this same clone of the remote repository, but at the end of the day, we are all trying to push into that central location, and it's only gonna ever be one single file. That single file in that a single version of that file is what we want to do. So we want to push it into that central location. So it's the origin, and then main defines the branch. So what branch? Main branch. So when we hit this, it has been pushed into the remote repository. So now when we refresh, we will see the UI change. Now it has changed. What do we see now? Test.txt is now pushed into the repository, and one line of code, hello from dev1. So what happens now is, if I ever send this repository link to anyone in the organization, if I do this, tell them to git clone on their own computer, tell them to git clone, they are going to see this file in their own local computer. So how do we simulate that? Let me, maybe from my terminal here, let's see. I can create a folder. Maybe I create a folder called git test, and then I can cd into the folder, and then I can run that command git clone. This is the repository URL. It has been cloned. So now when I ls, I'm going to see that file. So I see the when I ls, I'm going to see the repository. Now this is the repository, DevOps class test. To confirm, this is the repository name. So now in here, I will now go into, so this is like we are trying to test that this is someone else in another region in their own computer. So you go into the folder and is now going to see that file. See, test.txt, and if he cuts this file, he's going to see what I've written there. So you see it, hello from dev 1, hello from dev 1. So what am I going to do now? Let's say from this my VS Code, this Visual Studio Code, into this other tool called terminal, we will say this is developer 1 and then this is developer 2, for example, so that we simulate how you push and different people see it. So now I want to now make another change and then push it. So I'll write another line, hello from dev 1 again. Hello from dev 1 again. Save it, Ctrl S, you save, and then you come, you check your Git status. Let's clear. So this is developer 1 still doing his own thing. So Git status. So you see, Git has tracked this file, and Git is saying to us that this file has been modified. So we are okay with what has been modified, so we do git add dot to add everything. It has been added. Then we run git status again to see. Git now says modified and it is changed to green. That means Git has added it. Now we say git commit. We want to commit it -m. This is the command, and then we give it a new message, right? The commit message. Why are we committing it? Then we say made update to the file by writing a new sentence. So this has been committed, so we can push it again. So to push, git push origin main. Now this has been pushed. So when we check the repository, when we refresh, we will see that there has been an update. So you see this change. It said made update to the file by writing a new sentence. So that is the commit message. So now what do we see? We see the 2 lines of code now. So but on this second developer's laptop, what he still sees, if he cuts the file, he still sees this hello from dev 1. So he can be in maybe the US and I am in Nigeria, and then he thinks this is all there is in that file. But all he needs to do is to run this command, git pull origin main. Git pull origin main, and he's now going to, now the Git will then sync his own local computer with what is in the repo. So it has been pulled, and Git is letting it know that a line and some insertion has been made. It say 1 file change, 2 insertions, 1 deletion. So it's letting it know the changes that has been made. So now when he cuts the file again, let's clear the terminal. So now when he cuts the file again, he now sees what I've been written in there, what I have written in there. Now this is dev 2. So this is developer 2. So developer 2 now wants to now make his own push into the repository. So he can go into the file, he can use Vim if we have Vim installed. So he can now go into the file, we can use Vim if we have Vim installed, and then Vim test.txt. Okay, yeah, we have Vim. So we go into insert mode, and then he will say hello from dev2. He will say hello from dev2. Then we save the file. So now it has been saved. He will do git status. He will see that it has been modified. He will see that the file has been modified. He will also git add. The file has been added. Check the status. It says that it has been added. Then he will do git commit -m, making first commit from developer 2 making first commit from developer 2. So this has been committed. Then he will push git push origin main. These are the commands. He has now successfully pushed into the repository, and when we refresh, we are going to see that the push has been made. So now we see it, hello from dev2. We see it in the file. And we see the commit has changed. It says making first commit from developer 2. So now this developer 1 in here, this is what he still sees. He still sees this. So for him to now see or know that a new change has been made into that repository, then he's going to git pull on his side. So everyone is git pulling before they make their own changes. They always occasionally git pull origin main, and now the update has been made into his own version of the file. So now this is how they keep in sync, knowing that whatever this one does, he pushed it into the repo, and we are also able to see it. So in our classes, we'll be seeing how we are all going to be pushing codes into a central repository from each of our own computer, and then see the changes. We are going to be looking at git merge, raising merge requests. We are going to be looking at actually solving git conflict when any conflict happens. Okay, so now let's talk about merge conflict. So merge conflict is, this happens when, for example, a developer, let's say developer 1, makes a change and push it into the remote repository, and then developer 3 makes a change, another different change on the same line of code, right? That means the developer 2 did not pull the latest changes from the remote repo before adding his or her own changes. So let's take a practical example. So let's say this is dev4, and this is what is in the remote location. Let us check. Okay, what is in the remote location is this dev3. So this developer needs to pull git pull origin main. Okay, so we've seen the changes now. We've seen the changes. So this developer also needs to pull git pull origin main. So now let's cut what's in the file. So yeah, everybody is on the same page. So this first developer this first developer will then write, or let's say he makes a changes this one to dev 4, for example, and then clear the screen. And then he adds the changes, checks the status, it has been added, then commits it. Okay. Commits it and then git push origin main. So this has been pushed. We can see that this has changed to 4, from 3 to 4. Now this developer, if we cut, is still having it as 3. So now he wants to make a change on this same line, not knowing that it has been changed. So we can see that this developer is not currently having the most latest version of the file. So he goes in here, insert mode, and then he changes this to 5, right? What is in the remote repo is 4, and he is trying to change it to 5. So save, write and quit. Saved. Then he tries to add it. Git status, it has been added. Git commit, we will say testing merge conflict. Then git push origin main. This is going to fail because it's going to have a merge conflict. So we see it, merge conflict, because he is trying to change what is on the remote repo without being up to date with the remote repo. So it's trying to change the same line and is not up to date with the remote repo. So you need to always be up to date with the remote version, the version that is on the remote repository. You need to be up to date before you make a push. So that's why each time before you make a push, it is advised to pull. So you work on your lines of code for maybe a day or an hour or couple minutes, but before you make a push, you try to make a pull, because if you have a lot of developers doing different things and pushing into that repo, then you want to be always pulling the repo so that you have the latest changes, so that you don't run into merge conflict. But in cases where you eventually get a merge conflict, the command to run, the idea of a merge conflict is for you to have that you will see in the file the message or the script, or let's say the lines of code rather, that was written by the other developer that is already pushed to the repo, and your own lines of code that you are trying to push. So what you are now going to do is you're going to edit the file to either remove your own lines of code and keep that developer's lines of code, or you remove the developer's lines of code and keep yours, or you put yours in a different line. So we are going to see that shortly. So the command to run is git pull. You are now going to try to pull the origin. Git pull origin main dash no rebase. So this allows you to pull it while seeing the both changes. So now this has been pulled. So it says automatic merge failed, fix conflict, and then commit the result. So now we can now cut the file. Do you see this new stuff? This was added by Git itself. This head, this, and then this, right? This was added by Git. So we can go into the file and then make the changes. Now when we go into the file, we see it, right? We go into insert mode. We see this is telling us that our current local Git, the head, is this our new change. This is our new update, which is hello from dev 5. But what is on the actual commit in the repo is hello from dev 4. So what do we want to do? So what is on the actual repo is hello from dev 4. And what we have in our local Git is hello from dev 5. It's our choice to either keep the other developers work, or we remove it and keep ours, or we put ours in a different line because we were trying to put it on the same line. So now you remove this from your file. So let's keep the other developers code. We'll keep it as it is, so ours will go below, and then you save. Then we git add, we commit, then we push. Now it has been pushed successfully and we have resolved the merge conflict. So let's see. Now we see it. So that's how to resolve a merge conflict. So next thing, let's look at branching. We talked about creating a branch, right? So let's look at branching. So to create a branch, which I already explained earlier, the command is git branch, and then the name of the branch will say James branch. It has been created. A branch has been created. So now we can go into that branch. We can switch from our main branch, which we are on, so we can see how many branches we have on our repo by doing git branch. You see the branches. Then the one with star means is the branch you are on. So if we want to switch into this James branch, then we do git checkout. That means I'm checking out from main into James branch. Checkout James branch. So here it says it has switched to branch James branch. So when we do git branch again, we'll see that now we are now on James branch. So I can try to do git status on this branch. So it's clean, right? It's clean. I can make a change on this branch, and that change on this branch will not affect the changes in main branch. They are always going to be separate until I try to merge my James branch to my main branch before they can have the same thing. So I can write a new update. I can say demo James branch. So demo James branch, this will only be in this file in the James branch, but when you go to main branch, you will not see these lines of code because we've not merged it into the main branch. So we are now doing something separately, not affecting the main branch. We are doing it on our own separate branch. So that's the concept of raising a merge request. So when I'm done with this and I like it, then I can raise a merge request. So do git add. We can do git status to see. Modified, then git add, then git commit. We can say making a push to James branch. Then we can do git. This is where you now see the difference. Git push origin James branch. So the branch you're on is what you will put here as your push. So now it has been pushed. So when we go, we are still on the main branch, so you will not see that line of code, right? So we don't see that line of code, but now here is where you see your branches, because it shows we're on the main branch. Now when we open up, we see James branch. James branch has now showed up here. Then when we switch it, you now see these lines of code. James branch, you now see these lines of code. But when we switch back to main, we will not see it, right? So that's how we keep things separate. Then a merge request can be raised. We are going to be seeing how to raise a merge request in the actual classes that we will have. All right, so this is what it looks like. I will be doing that demo in the class. So yeah, this is basically Git. We'll be looking at more Git commands, but these are like what you can have as just a tutorial video, short tutorial video for you to get along and begin practicing. So yeah, thank you for your time. See you in the next tutorial.